Greetings, welcome to another fun video from iCampSA. So today we are doing Newton's second law. This is the 2025 May-June question paper. Okay, so let's have a look. So here we are saying a crate of mass 25 kg slides down a rough surface. Okay, so we're going to note our keywords as we move, right? A rough inclined plane at a constant speed of 2 meters per second towards point A, while force F is exerted or X on it. So parallel to the incline, okay, is shown below. So now a constant kinetic frictional force of 40 newtons acts on the crate when the plane is inclined at an angle of 30. This is our 30 here. Okay, so let's get into it. What are they looking for from us? So here they're asking us to state the Newton's first law of motion in weights. Okay, so now we must remember this is the first law, so we must always know it. So here we're talking about a body that remains at the rest, right? It will remain at rest, or it will remain in motion. If it's moving, it will continue moving. If it's not moving, it will continue not moving, unless a non-zero resultant force acts on it, or unless something pushes on that box that is not moving. Okay, that's what the first law is saying. Let's write it in weights. So it says a body remains in its state of rest or motion at a constant speed. So if it's moving, it moves at a constant speed unless a non-zero resultant force acts on it, unless a force that is greater than zero. So we can't say the force is zero and it does any difference to a moving object. So it must be greater than zero. So that's what this is saying here, a non-zero force. Okay, so let's go to 2.2. So they're asking us here to draw a labeled free body diagram showing all the forces acting on the crate, right, as it moves towards point A. Okay, so let's start. So this is 4 marks, so we should at least expect 4 forces. Okay, so we have, let's use another color, have 2.2. so a free body diagram, we're going to use a dot notation. So that means we're going to have our dot here, our dot. So first things first, forces that we know must be there is weight, normal force. So since here we know that this is on an inclined plane, I prefer doing something like this so that my forces are pointing in correct direction, right? So let's start. We're going to have weight here, Fg, which is facing down like this, right? This is gonna be our Fg. And then normal force is always perpendicular to the ground, to the surface. So this is going to be our normal force, which is Fn or N, just N. So we can just put N instead. Let's put N, right? And then we've got applied force, which they've told us about. So we already know this force that is applied here. This is force F. Okay, this is F. So now I must remember that this is moving down the incline. It's going down. And here they're telling us about the rough inclined plane. That means there must be friction there, right? They are not saying it's friction there. So that means since it's moving, we need Fk, right? You're gonna have Fk. Fk. This is gonna be Fk here. So now we have 4 forces. All right. So there's You can also calculate this in terms of components. You can leave it like this. You're still gonna get the full marks. Okay? Now let's move. So here they're asking us now to calculate the magnitude of force F. What is force F? Okay? Now let's get into it. Let's do some fun stuff. So one of the fun stuff that we are going to do is to say Fnet is equals to ma. This is your mass, this is your acceleration. Okay? This is a vector, right? That's how we write it. That means a vector has magnitude and direction. That's what we are basically saying here. So now something to note here, to what they've told us also, something very cool is that this thing is moving at a constant speed, right? So at a constant speed, we are saying all the forces are at equilibrium. So all the forces acting around the object are equal, right? That's what we are saying when it moves at a constant speed. Hence this law here, first law, is saying unless a non-zero resultant force acts on it. So remember what's like, listen to what this law is telling you. They're saying it will continue at this motion at a constant speed unless this non-zero resultant force acts on it. So here it's moving at a constant speed, which is being set by the first law. So we will not be wrong to say Fnet is equals to 0. Yes? Okay. Hope it makes sense. So now we can go back, and then we've got these forces already. So now it means we can't be able to calculate everything we are looking for. But we must be careful. Okay? We must be careful. Why must we be careful? Because, so here, let's do this. Here, this thing here is at an incline. Since it's at an incline, we are going to have components. The weight is going to have components, right? This is what is going to happen here. The weight is going to have components. So it means we are going to have, let me just update here. We are going to have, this is going to be Fg parallel, because it's parallel to the surface. And then this here, we are going to have Fg perpendicular, right? We've got these for two forces. So these two forces represent this Fg. So we must be able to calculate these two. Okay? We must be able to calculate these components. So it means here now, for our Fnet, if we do Fnet, we can say Fnet is equals to, we've got force Fg. Let's choose downwards as positive. If we're choosing down as positive, Fg is going to be positive, then plus, this is going to be minus F, which is this F, plus minus Fk, because they are going at an opposite direction. Okay? Which we can solve it and just say is equals to Fg parallel minus F minus Fk. Right? Then you can get what we are looking for. Right? We are making it easy. So for our Fg, we are going to have, this is going to be mg, this is our weight, sine theta minus F minus Fk, right? So theta is 30 degrees, and then mg, this g is 9.8. It's a constant. So that means we are going to have 25, which is the mass, and then times 9.8 sine 30. We are looking for F, so minus F minus Fk. Did they give us? Yes, they gave us 40 newtons, right? Remember, Fnet here is equals to 0, right? So now it means you can just bring 1 to the other side, and then we get our answer. Okay? So let's do this. We're going to have F being equals to 25, 9.8 sine 30. all minus 40. Right? And then we've got our F. So let's punch in our calculator and see. So from my calculator, we get 82.5 newtons. Okay? This is it. Now, let's move to the second part. So, part 2 says, when a crate reaches point A, F is removed, right? Force F is removed and the angle of inclination is decreased immediately to theta, so that the crate continues moving at 2 meters per second towards point B. Okay? So now they're asking us here, use the relationship between forces acting on the crate between points A and B to show that mu k is equals to sine theta over cos theta. Right? More fun stuff to do. Okay, so we must know that Fk is equals to, this is a rough surface, right? 2.4. We must know that Fk, since it's a rough surface, is mu k times the normal force, right? Remember from here that the normal force now is no longer equal to Fg, it's equals to this Fg perpendicular here, right? So that means we are going to have Fk being equal to mu k all times, they start with Fg perpendicular like this, so that you see it. And then we are going to move to Fk being equal to mu k times Fg is gonna be mg cos theta. This is our perpendicular component. Okay, we've already gotten this, right? So then now we can move and try to get our force, right? But now remember again, let's go back here. So we must remember that because it's moving at a constant speed, they've told us here that it's still going to move at this 2 meters per second. So that means our Fnet, this means Fnet is equals to 0. Why? Moving at constant speed. Okay? So I will explain another time why it becomes 0 like this in a mathematical form. Okay? So we've got this. So that means since we've got this is removed, this F here is removed, then we've got Fk and this Fg now. Okay? These two forces are opposing each other. So that means we are going to have Fg parallel minus Fk being equals to 0. Then it means Fg parallel is now equals to Fk like this. Okay? Hopefully it makes sense. What have I done here? I just took Fk to the other side, right? So if we then move, we are going to say Fg parallel. Remember Fg parallel. What is Fg parallel? This is Fg parallel here. That means we are going to have mg sine theta being equals to, this is Fk. Fk, we already have it here, which is mu k times mg cos theta, right? Then we're gonna divide. Let's divide because we're looking for mu k. So we can divide by mg cos theta, mg cos theta. This goes away. So now we are left with mu k. This goes away also. So it's gonna be sine theta all over cos theta. Okay? So now we have proven what needs to be. Right? Hopefully it makes sense. So let's move to the last question. Okay, so last question. What do they need from us? So here they're asking us the coefficient of kinetic friction between the crate and the inclined plane is 0.19. That means mu k is 0.19. Okay? Using the identity sine theta over cos theta is equal to tan theta. Shout out to maths, right? Trigonometric functions. So now calculate the frictional force as the crate slides down from point A to point B. Then, how do we then calculate it? What we know that here is that we have, this is mu k, so that means we can say 0.19 equals to sine theta all over cos theta, like this, right? But because they are telling us to use this identity here, that means we are going to say tan theta being equals to 0.19, right? Yes, we are almost there. So that means we can come here then and say, what is theta? We can say theta is then equals to arctan, like so, right? Then we can get our theta. What is our theta then? Then we end up with 10.76 degrees. Okay, we are not done. We are not looking for theta, but we are looking for the frictional force, right? So we already have the frictional force here. This is our frictional force here. So that means we can go back and say Fk is equals to mu k. Mu k they've given us is now 0.19. So it's going to be 0. Let me write it first. We're going to have mu k, then mg cos theta, like so. And then we're going to have 0.19. What is the mass of our crate is 25. So the mass of our crate is 25, excuse me. And then we have 9.8 cos 10.76. Okay, this is what we then have here. So let's punch in our calculator and see what we get, right? So we then end up with 45.73 newtons. This is our final answer. Okay, great stuff, guys. Hope this was fun. Until we meet next time.